When studying simple one-dimensional motion, something that doesn't often come to mind immediately is the movement of electric current. Current in physics is given the variable capital letter I and is defined as the movement of electric charge. For our purposes, we'll mostly be looking at movement of charge as a conductor through metals, right, such as wires. In those cases, the current that is moving is actually an electron that is sliding around the valence electrons of the crystal lattice of the particular element, whether or not it's silver or copper or gold. Those electrons move essentially as a linear velocity from one side of the wire to the other side. This movement can be identified in your basic formulas of movement as V equals d over t. That's called electron drift. And that energy, that movement of the electrons from one side to the other, creates a kinetic energy that ultimately can be harnessed, which is where we get electric power. In order to describe the movement of charge, it's useful to understand that although V equals d over t does apply, we can also put this in terms of charge moving in time. That requires us to introduce the charge unit known as a coulomb, or capital C. Coulombs will be discussed further when we describe the electromagnetic force in depth, but for now, most standard charges are going to be identified using their coulombic measurement. An electron has a negative charge that has a magnitude of 1.6 times 10 to the negative 19th coulombs. A proton would have a similar charge that is positive. Ions in chemistry would have varying charge values that are all integral factors of this particular value, right, as atoms either gain or lose electrons. Once you have that foundation, the formula for current is relatively simple. I, as I told you, is the variable, and we're going to measure this as the change in charge in a unit of time. As such, this would be coulombs per second as the units, which has its own term, capital A, which stands for amperes, A-M-P-E-R-E-S, and for oftentimes is simplified to amps, so that A is not confused with other variables. As long as your units are in coulombs, this is in seconds, this is standard SI basis, and then calculating current is relatively straightforward. We'll be utilizing that current in a formula called Ohm's law later when we analyze electricity a little bit more.